Hi, I'm Brian Bentley, and I hope you'll excuse me, but I've got to keep working. As you can probably tell, I'm helping decorate for my little brother's birthday party, if you could call 6'4" little. He's still in high school, but he wants to study chemistry in college. So I've made that the theme for his party. What do you think? He had a pretty extensive wish list, but in keeping with the theme, he'll have the opportunity to choose his gifts by selecting a couple of these element cards. He better choose carefully, or he might wind up getting a tin can, or a bottle of chlorine bleach, or a lead fishing weight. You know, until I started planning this party, I never realized how the elements play such a direct role in our everyday lives. I mean, I know that every physical object is ultimately comprised of some combination of the elements, but it's the elements themselves, and particularly their electron structures, that determine how they can be used. So, what's chemistry got to do with this party and with the way we live, work, and play? For example, if he happens to choose the card for element 22, titanium, I'm sure he'll be delighted. Titanium is one of the transition elements, or transition metals, found in this part of the periodic table. The transition elements include familiar names such as copper, iron, and gold. Less familiar names such as cobalt, tungsten, and chromium. And unfamiliar names such as scandium, vanadium, and niobium. Transition elements share many common properties, which stems from the similarity in their electron configurations. Because their electrons are loosely bound to the positive nucleus, some transition metals are excellent conductors of electricity. Transition elements will use electrons from both D and S sublevels to bond with other elements. Consequently, transition elements bond readily with each other and with many other elements to create a wide variety of stable and very useful compounds. The transition element titanium is an innately strong metal with a density that is much lower than metals of comparable strength. When it's alloyed with small amounts of aluminum or tin, titanium has the highest strength to weight ratio of any engineered metal. This makes it an ideal material for things like aircraft engines and for human joint replacement because it's lightweight, non-corrosive, and doesn't react with body fluids. Titanium is also ideal for consumer products that gain an advantage for their users by being light and strong. Golf clubs, baseball and softball bats, and a product of particular interest to my brother, bicycle frames. If he doesn't choose element 22, perhaps he'll be lucky enough to select number 14, silicon. Silicon is a metalloid, which means it possesses some of the properties of metals and some properties of nonmetals. The metalloids are found here on the periodic table between the metals and the nonmetals, of course. One unique property of metalloids is that they conduct electricity better than nonmetals, but not nearly as well as metals. For this reason, metalloids such as boron, arsenic, germanium, and silicon in particular are valuable as semiconductors. They are at the heart of today's electronic devices and computers. And once again, the element's characteristic properties and its potential for utilization are directly tied to the configuration of its electrons. Silicon, like the other elements in column 14 on the periodic table, has 4 valence electrons. This causes silicon atoms to form a crystal lattice structure in which there are no free electrons to move about. In this form, silicon is not a conductor or even a semiconductor, but rather an insulator, which prevents electricity from passing through. But adding small amounts of certain elements, a process called doping, gives silicon some unique and valuable properties. One of those elements is phosphorus, which we can determine by the periodic table has 5 valence electrons. So when it bonds with silicon, the 5th electron has nothing to bond with. Electricity flows through the material due to the unbonded electrons. This is called an N-type semiconductor, the N referring to negative. On the other hand, if boron, an element with 3 valence electrons, is added to silicon, there's a hole in the lattice where each missing electron would be. And once again, electricity can flow through the material, but in the opposite direction. This is called a P for positive semiconductor. P and N semiconductors can join to create a diode, which permits current to flow in only one direction. Or they can be sandwiched in an NPN or a PNP configuration to create a transistor, which can serve as an amplifier or a switch for electric signals. At the heart of every modern computer, there's a thin wafer of silicon, about 1 inch square, that holds millions, even tens of millions of these transistors. That tiny silicon-based microprocessor chip is the computer's central processing unit, and it can handle billions of instructions per second. But the only instruction my brother needs to know at this party is, choose element 14. By the way, I should mention that one element that's playing a key role in this party preparation is element number 2, helium. It's what's inside all of these balloons. Helium is a member of a family of elements that can be found on the far right column of the periodic table, column 18. This family is called the noble gases, and it includes radon, xenon, krypton, argon, and neon. They're called noble gases because under normal conditions, they don't react easily with any other elements to form compounds. Because they do not react easily, the noble gases were among the last of the readily available elements on Earth to be discovered. The reason they're stable is their outermost energy level is complete. In helium, that outermost energy level, the number of valence electrons, is 2. For each of the other noble gases is 8. There's absolutely no need to give up or accept an electron. And consequently, the noble gases are extremely stable. That's why the neon in the sign burns so bright and lasts so long when an electric current is passed through it, and why the gas used to surround and protect the extremely hot tungsten filament in an incandescent light bulb is a noble gas, usually either argon or krypton. Uh-oh, I think I hear my brother and the rest of the party group coming. He thinks they're just stopping to pick me up to go skiing. Skiing. Oh, see you next time.